Hey everyone. So I want to start a new series called Tutorial Tuesdays, where I go over some really uh, not simple but quick tutorial. The attempt is to add some variety to the channel because a lot of this stuff right now is like these 30-minute lectures essentially. And so I want to try and create these like short, quick videos of just little tricks that you can use in your projects all the time. So the first trick that I want to do for today, and fair warning, this is probably not going to be every Tuesday, but I have a couple of these set up, so hopefully I can be pretty consistent. And if you have any ideas of what you want, by the way, like if there's a particular thing that you're curious about, I'm happy to look into some of that stuff. So leave suggestions in the comments. Okay, so anyway, in programming, not just C++, but really any programming, you will often have some kind of, array like this. And this can take the form of, any number of things, but a common thing, in C++ is to use vector. And so, what we commonly have is there might be a bunch of values in here. 952, it doesn't really matter. Although I've screwed this up already because these are all sorted. So let's change this to, it doesn't matter what these are. 1592, 100. Doesn't really matter. So a lot of times what'll happen is you want to iterate through this array. And you might say, okay, everything greater than 50 I want to delete. So you might delete this guy. And so on. And you want to go through and you want to delete all the things that are greater than 50. And so this has a lot of issues. One issue is as I'm walking through this, once I hit this guy's gonna start walking, it has to go and walk all this stuff down. An array is defined as a contiguous block of memory. So in order for this stuff to be valid, generally it's gonna have to walk down. There's other methods. You could just leave this empty, but if you want to basically keep this array in the same way, you want to kind of walk it down. Now, there are several, if you're using standard vector or some version of that, here's vector here. They have, where is it? Modifiers, here it is. I'll zoom this in a bit. They have things like erase. So this erases elements. If I just click on this guy and we can look at what this does, it takes in an iterator or a range of iterators if you want to do that. So this iterator will do the magic for us. So if I call, if I'm just looping through some array and I call erase on some iterator that's dealing with that array, it's going to erase it and shift everything down. But the problem there is you're going to invalidate a bunch of stuff and all that. And there's ways kind of around that as well. But the biggest issue here is if I want to erase, 5, 6, 7 elements, each one of those is going to require me to go through basically the array. Let's say if I just erase all this stuff, let's say that I want to erase all elements sort of that are less than or equal to 75. So what's going to happen is I'm going to erase this guy, walk everybody over, right? All these guys have to walk over. Then I'm going to erase this guy, and all these guys have to walk over. And this guy, and all these guys have to walk over. This guy's okay. Then I have to erase this guy, and everything walks over, right? And you see what's going on, and I'm left with 2 elements. So the worst case, what's the worst case? The worst case is that I have to erase everything, that I do something like less than or equal to 1,000. Now I have to erase everything, which means that I'm walking through the array I have to walk through the array, and for each one of those elements, I'm essentially walking through the array again. To kind of go into computer science land, this is effectively n squared. It's not exactly n squared, but it's effectively, approaches an n squared type problem. N squared is not good. We don't want that. What can we do? There's a few things that we can do. If this is sorted, then we can search for particular elements. We can search for, the element of for example, if this was sorted and I was looking for everything that's less than or equal to 50. I would search the array for 50, and then I would know that everything to the left of the array can be erased, and I would erase the entire range, so that's pretty efficient. Specifically, since we're in computer science land, that would be log n to find it, and then there would be one, because worst case would be everything, so there'd be one kind of n thing, so you'd essentially get an n log n erase time, and so that's pretty good. But there's a trick that we can do, which I will call the swap trick. If the array is unsorted, then we don't care what, where these elements are. We don't care at all. So that means we can actually do it in constant time. The way that this works is, let's say I'm trying to erase everything less than or equal to, we'll go back to what I had before, 75. So in this particular case, what we're going to do is we're going to say, okay, no, here's one. We're going to, instead of just erasing it here, we're actually going to do a swap with the last element. So the new array is, I'll do it in yellow. The new array is, this is going to be 92, and then this is going to be 100. And then we're going to do vector has one already called pop back, which is a constant time thing. It just shifts a little pointer over. And so now this guy's gone. So this happens in constant time. This is a constant time function. And then we just don't increment the iterator, so we search again. Oh, look, it's the same thing. We have the same issue. I'll do this one in red. So we, once again, swap. So this guy becomes 100. This guy becomes 52. We kill this. Then we don't increment. We do the same check, and it's like, okay, this is not one that we want. And we keep going and going. And as we're doing this, you know that vector has this concept of, and STL structures do this concept of end, or whatever or size, whatever you want. And you have to be a little careful using iterators for this, because some of these things will invalidate iterators. The size is constantly changing, right? Size is going to go down every time I call pop back. So this is the new size, although I guess technically this. So I'm just checking to see if I'm less than size as I keep going. And so this swap trick is a very, very fast removal. And this isn't just C++. You can do this anywhere. So I have a little demo for this, one of these guys. Tutorial Tuesday, here it is. So this is my little demo, and I'm just going to walk through it very briefly. I tried to set up like an actual use case for this, and then we'll write the code itself. The use case for this is that I have this timed thing. It doesn't really matter what it is. In my case, I just have a timer, which is a frame counter, and then just data. I don't know, I threw a string in there, it's fine. And then I have just this constructor that constructs it, and then I have an update. So the update returns a Boolean, and so I subtract, I just minus on this thing, right? I just decrement this counter. If the counter reaches 0, then I return true. Otherwise, I'm returning false. So the idea here is, once this update returns true, I need to remove it. I also have a little getter here to get the data. So I set this thing up where I just have these guys. I guess I don't need rand. So I just have a vector. So it just sets up this vector. I don't know if you've ever seen this sort of calling convention or this syntax here, but it basically just constructs 3 timed things inside of this vector. So I have, this guy's going to last 3 frames. This guy's going to last 2 frames. This guy's going to last 5 frames. The loop is pretty straightforward. I don't really need to go too much into it. I just add some frame counter that I have here. Check to see if I use Q so we can quit at any time. And then I go through here and I call this update. The update's going to do our update and then some stuff. I don't know. Like, this is the thing we're going to write. And then this is our display down here. So it just prints it out. This actually runs, if I run this now, then and all it's going to do is it's going to print the same thing. I'll zoom this guy in. It's going to print the same thing over and over and over because I'm not removing anything, right? So it's just going to keep doing that until I hit Q, and then I'm done. So that's what we got. So now what I want to do is I want to set this up so that, you know, I don't think I'm going to show the slow way because that's just erase. So I want to set this up in such a way that we are kind of looping through this thing and doing this little swap trick. So the basic way that this works is like this. Oops, not here. So in order to do this, I kind of have to change the way that I'm updating this, because I can't just kind of use this automatic thing here anymore. I have to do a different method of updating. So I'm actually just gonna do kind of what I think is a simple version. Iterators get invalidated and they're kind of a pain in the ass in some cases. So I'm just gonna do this like really simple method. Time things dot size plus I. So very, very basic forward iteration, just using an index, right? So far I haven't actually changed anything. I'll copy and paste this guy. Except now it's not timed thing, it's timed thing sub I. And then we're going to get rid of all this stuff. So this is kind of our new loop. It's the exact same loop, except I'm going through it in a different way. Okay, here's the thing. So if I am, we'll go back to our list here. So if I am, if the condition is true, I need to swap it with the back. So that's easy. There's actually a function just for that, right? There's a swap in the STL. And it takes in the things that I'm going to swap. So I'm going to say timed things sub I, and then timed things, and then there's just already kind of a back function, and that's the easiest thing. So this will swap with whatever is at the end with my thing. So it does this swap right here. So then I need to do, where is it? Timed things dot pop back. So that's going to change this guy, so that it basically kills this thing. You know, it's not actually going to deallocate memory. I may go do a whole thing on how vectors work, but what it actually does is internally there's some kind of like, it's actually end. It's called something different in different things, but there's actually some kind of, you know, end pointer that it just sort of moves back. So that's all it's really doing. It's essentially changing what size is going to return, which is what we want here. So it's going to kill this thing, and it's going to destruct it and all that fun stuff. So this string will get destroyed and everything. Now the other thing is, remember that we don't want to increment in this case, because remember in our example, that 100 is valid to be removed as well. So that means we can't do this sort of auto increment every time, because we don't want to increment here. We want to process the same index. So we just create a little else here and increment in this case. And that's it. That's how we set this thing up. It's this entire, this is it. So this will be a very fast update. So that means that, you know, we walk through everything to do this update, but the actual removal of the item happens in constant time, which is very much better than linear, which is really going to be linear for each element in the absolute worst case. So we have, you know, we've gone from n squared to constant, which is pretty good. Big caveat: this only works in on unsorted arrays. It only works on unsorted arrays. Sorted arrays obviously is not going to work, because if this guy's sorted, then I'm swapping orders of things. So then you have to do something else like this nlogn thing. All right, so let's build this guy. I am going to set a breakpoint here. Actually, I might set it up in this update. No, this is fine. So I'm going to set this breakpoint here. We're going to run this guy. Okay, ready to go. So we're going to be ready to go. And we'll watch this guy. Well, let's actually just verify that it works. So I'm going to do this. There we go. I've lost one. I've lost another one. Rat lasts for a couple frames, and then I'm done, and there's nobody. So it correctly removes them in the order that I would expect. So that's good. You know, let's run this guy again. Now we'll set this breakpoint. And here we go. So we're going to just watch this guy run. This update, oops, if I go here and I go to autos, you may not be able to see it, but I can see that update returned false. So since it returned false, there's nothing for me to remove. It's going to increment I. So we're going to move to the next element. Again, we're going to increment I, move to the next element because this returned false. And same thing here. So the first frame, nothing interesting happened. So if I hit it again, and we go to the second frame, this is where the first interesting thing happens. So nothing for the first guy, because remember, we're going to remove dog now. The second guy, here we go. So if I look at timed things, I'll look at it in a watch here. And this is going to be a little hard to see, so I'm going to try and set this guy in a reasonable position. All right, that looks like it's good. Yeah, let's try and do that. Okay, so hopefully you can see this. So here are my 3 elements, right? This timer is at 0, as we can see. Dog is at 0. So what we're going to try and do is we're going to try and swap it with whatever the last element is, in this case, rat. So that's the first thing we're going to do. Now we just swapped them. We can see that dog and rat have changed. They've exchanged positions. And now we're going to pop back. So we're going to see this array go from 0, 1, 2, these 3 items to go to 2 items. So now we have 2. It collapsed because now we have 1 less item. So now we have cat and rat and nothing else. And we don't increment because we still need to process rat. So we go back and we update rat. We notice its timer went down. It's not time for it to be destroyed, so we're good. And then that's it. So if we hit this, hit that, and then go back to this guy to see what the next element is, let's process the first item. This one's cat. Okay, so now cat's gone to 0. Again, we do the swap, so cat and rat have exchanged places. We pop back. We still need to process rat, so we didn't increment I. I guess we can put I here. So I is still 0. So we have to, so we didn't increment it, and then we processed the next guy, which is rat. We see that it went down by 1. It's timer. So now we can run this. I'll step again. Now, nothing's going to happen here, right? We just update and increment because rat is not ready to be updated. So now for our final loop, we have update. Rat goes to 0. We do a pop back. We do a swap. So we swap rat with itself, which doesn't matter and does basically nothing. And then we pop back. Size is 0. We need to try and reprocess, right? The same index. So, but now I is less than 0, right? I is less than size is no longer true because size is 0. So this loop ends. So that safely ends. And that's it. So now we can just keep, doing this forever and ever, but now the loop is empty. So now we're done. We can just keep going here and it's going to be frame nothing. So that's the idea. That's how you do the swap trick. So I hope that was useful. Let me know if you have any questions or comments. Feel free to leave them down below. And that's it. I hope this was useful. Again, any suggestions that you have for particular tutorials you want or anything like that, I'm happy to do them.